Volcanoes. They are among the most awe-inspiring and powerful natural phenomena on Earth. They are mountains, but not just any mountains. They are mountains with a fiery heart, capable of reshaping landscapes in an instant. They are mountains with a fiery secret, a secret that lies deep within, waiting for the right moment to reveal itself. Deep inside, they hold molten rock, yearning to break free. This molten rock, known as magma, is the lifeblood of a volcano. Volcanoes are vents in the Earth's crust. These vents allow the magma to escape, creating spectacular eruptions. These vents act like chimneys, connecting the surface to the Earth's fiery interior. Through these chimneys, the Earth releases its pent-up energy. Imagine a world where the Earth could breathe fire. That's the world of volcanoes. That's what a volcano does. It breathes fire, ash, and molten rock, transforming the landscape in the process. It's a reminder that our planet is alive, a dynamic force of nature. The eruptions are a testament to the Earth's ever-changing nature. Volcanoes come in different shapes and sizes. Each one is unique, shaped by the forces within the Earth. Some are tall and conical, like the majestic Mount Fuji. These stratovolcanoes are known for their steep profiles and explosive eruptions. Others are broad and shield-like the volcanoes in Hawaii. These shield volcanoes have gentle slopes and produce large, flowing lava fields. No matter their shape, all volcanoes share one thing in common. They hold the potential for incredible power and destruction. They hold the potential for incredible power. When a volcano erupts, it can change the world around it in an instant. When a volcano erupts, it's a spectacular and awe-inspiring event. The sight of molten rock and ash spewing into the sky is both beautiful and terrifying. It's a reminder of the immense forces that shape our planet. These forces are a testament to the dynamic and ever-changing nature of the Earth. Deep beneath our feet, the Earth is hot, really hot. The temperatures are so extreme that they can melt rock and metal. The Earth's core is a ball of iron and nickel, heated to over 9,000 degrees Fahrenheit. This core is the powerhouse of our planet, generating immense heat. This heat radiates outward, affecting the layer above it, the mantle. The mantle, in turn, becomes a dynamic and ever-changing layer due to this intense heat. The mantle is a thick layer of rock, extending for thousands of miles. It's a vast rocky expanse that plays a crucial role in the Earth's geology. But it's not solid rock. The heat from the core causes parts of the mantle to become semi-molten, creating a unique state of matter. The intense heat from the core partially melts the mantle rock, turning it into a viscous molten state. This molten rock is called magma. Magma is the lifeblood of volcanic activity and the source of many geological phenomena. Magma is a complex mixture of molten rock, dissolved gases, and solid crystals. It's a dynamic and ever-changing substance, constantly evolving as it moves. Imagine a thick hot soup, bubbling and churning deep underground. That's magma. It's a seething, boiling cauldron of molten material. This magma is less dense than the surrounding solid rock. Because of this, it has a natural tendency to rise, much like a hot air balloon. So it rises, seeking a path to the surface. This journey is fraught with obstacles, as the magma must navigate through solid rock and other geological barriers. The journey of magma is a slow and relentless process. It moves inch by inch, driven by the immense pressure and heat from below. It can take thousands, even millions of years for magma to reach the Earth's surface. This slow ascent is a testament to the power and persistence of geological forces. But when it does, the results can be explosive. The sudden release of pressure can cause dramatic volcanic eruptions, reshaping the landscape in an instant. As magma rises, it often collects in underground chambers. These are called magma chambers. Think of them as giant holding tanks for molten rock. These chambers can be enormous, stretching for miles beneath the Earth's surface. Inside a magma chamber, the pressure builds. It's like a pressure cooker. The weight of the overlying rock pushes down on the magma. This traps the dissolved gases within the magma. The longer the magma sits in the chamber, the more pressure builds. The pressure continues to increase until it exceeds the strength of the surrounding rocks. When that happens, an eruption is inevitable. The Earth's crust is not one solid piece. It's a complex, dynamic structure that constantly changes over time. It's broken into massive slabs called tectonic plates. These plates are like giant puzzle pieces that fit together to form the surface of our planet. These plates are in constant motion, driven by forces deep within the Earth. They move at a rate of a few centimeters per year, which might not seem like much, but over millions of years, it adds up. They collide, separate, and slide past each other. This movement is not smooth. It's often jerky and can cause significant geological events. This movement is what causes earthquakes. When the stress between plates becomes too great, it is released in the form of seismic waves shaking the ground. Tectonic plate movement also plays a crucial role in volcanic eruptions. The interaction between plates can create pathways for magma to reach the surface. When tectonic plates collide, one plate may be forced under the other. This process is called subduction, and it occurs at convergent boundaries. The sinking plate melts as it descends into the hotter mantle, creating even more magma. This molten rock is less dense than the surrounding solid rock, so it begins to rise. This magma rises, adding to the pressure building in magma chambers. Over time, the pressure continues to increase as more magma accumulates. Eventually, the pressure becomes too great for the surrounding rock to contain. The rock above the magma chamber fractures, creating cracks and fissures. This creates a pathway for the magma to escape. The magma moves through these newly formed pathways towards the surface. And that's when the eruption begins. The magma, now lava, bursts forth, releasing gases and ash. The release of pressure is sudden and violent. It can send ash clouds high into the atmosphere, and lava flows down the sides of the volcano. It's a dramatic release of energy that has been building for centuries, even millennia. These natural processes remind us of the dynamic and ever-changing nature of our planet. Section 5. Eruptions, nature's fireworks display. Volcanic eruptions are not all the same. They can vary in size, duration, and explosiveness. Some eruptions are gentle, with lava oozing slowly from the vent. Others are explosive, sending columns of ash and gas high into the atmosphere. The type of eruption depends on several factors. These include the composition of the magma, the amount of dissolved gases, and the shape of the volcanic vent. Effusive eruptions are characterized by the outpouring of lava. This lava flows downslope, creating rivers of fire. Explosive eruptions, on the other hand, are much more violent. They eject ash, gas, and rock fragments high into the air. These eruptions can be incredibly destructive, devastating entire landscapes in a matter of hours. Section 6. The aftermath, a changed landscape. Volcanic eruptions are destructive forces. They can reshape landscapes, destroy forests, and bury towns and cities under ash and lava. But they are also creative forces. Over time, volcanic eruptions can create new land. The Hawaiian Islands, for example, were formed by volcanic eruptions over millions of years. Volcanic ash, while initially destructive, can enrich the soil. It provides nutrients that make the land fertile. Volcanic activity also plays a role in shaping the Earth's atmosphere. Gases released during eruptions contribute to the planet's climate. Section 7. Predicting the Fury volcano monitoring. Volcanoes are unpredictable, but scientists are getting better at predicting when an eruption might occur. They use a variety of tools and techniques to monitor volcanoes. These include seismometers, which detect earthquakes, often preceding eruptions; gas sensors, which measure the release of gases from a volcano, indicating changes in magma activity; ground deformation instruments, which track changes in the shape of a volcano, signaling magma rising to the surface. By carefully monitoring volcanoes, scientists can issue warnings and help people evacuate before an eruption. While we can't prevent eruptions, we can at least try to be prepared for them. Section 8. Living with volcanoes, benefits and risks. Volcanoes are a double-edged sword. They pose risks, but they also offer benefits. Volcanic soils are incredibly fertile. They are ideal for growing crops. Geothermal energy, a renewable source of energy, is harnessed from volcanic areas. Volcanic landscapes attract tourists. People are drawn to the beauty and power of these natural wonders. Living near a volcano can be risky, but for many, the benefits outweigh the risks. Section 9. Famous eruptions, stories from history. Throughout history, there have been many famous volcanic eruptions. The eruption of Mount Vesuvius in 79 AD buried the Roman cities of Pompeii and Herculaneum. The 1883 eruption of Krakatoa was one of the most powerful volcanic explosions in recorded history. The 1980 eruption of Mount St. Helens in Washington state demonstrated the destructive power of volcanic mud flows. These eruptions serve as stark reminders of the awesome power of nature. They also highlight the importance of respecting the forces that shape our planet. Section 10. Volcanic landscapes shaping the Earth. Volcanoes are not just isolated mountains. They are part of a global system. Most volcanoes are found along the boundaries of tectonic plates. These are known as volcanic arcs or rings of fire. The Pacific Ocean's Ring of Fire is a prime example. Volcanic activity has shaped the Earth's surface for billions of years. From the highest mountains to the deepest ocean trenches, volcanoes have played a role in creating the landscapes we know today. Section 11. Conclusion. The power and majesty of volcanoes. Volcanoes are a reminder of the incredible forces at work within our planet. They are windows into the Earth's fiery interior. While they can be destructive, they are also creative forces, shaping landscapes and influencing life on Earth. Understanding how volcanoes work is essential for mitigating their risks and appreciating their role in our planet's history. In this chapter, we will explore the largest volcanic eruption ever recorded, its impact on the environment, and the lessons learned from this catastrophic event. The eruption of Mount Tambora in 1815 is considered the most powerful in recorded history, leading to the year without a summer, due to the massive amount of volcanic ash released into the atmosphere. The explosion was heard over 1,200 miles away, and the ash column reached over 43 kilometers into the stratosphere. The vast quantities of ash and sulfur dioxide injected into the atmosphere created a volcanic winter. Global temperatures dropped by as much as 3 degrees Celsius, leading to the infamous year without a summer in 1816. Crops failed, livestock perished, and famine and disease spread across the northern hemisphere. The 1815 eruption of Mount Tambora highlighted the need for better understanding and monitoring of volcanic activity. The legacy of Mount Tambora continues to inform and inspire, reminding us of the delicate balance between destruction and creation in the natural world.